Alright, so we have our first experiment. We're going to start in a circuit, and the circuit's going to be our first LED and how to light it and how to get the most out of it. So this is an unknown LED. It has no value whatsoever. It didn't come with any cards whatsoever. It came in a pack like this. Okay, no labels, no nothing. So a little prerequisite, you should be familiar with LEDs, resistors, batteries, and breadboards. So those are in the components section before we do this experiment. So this is called the LED experiment 1. Something like that. I'll work on the title later. Alright. So the first thing we're going to do is we're going to safely lit the LED. Alright, so now we have our first experiment. We have a circuit, and the circuit is going to go like this. Okay, so boom. Now we don't have a battery per se, we have a breadboard power supply, so we're just going to draw this as a formality. Okay, we got a resistor. Okay, we got an LED. Okay, lights. Alright, so we got an LED, it's an unknown value, and we know that LEDs do come in a range. So they come in this range right here, anywhere from 1.5 volt to 3.6 volt usually. And certainly they can go a little higher than that, but not this one. This one's definitely a cheap little LED. And they can go from 10 amp to 15 milliamp. Alright, so based upon previous lessons that I've done, I'm going to choose something within this range. Okay, but as you go on, you can do the same thing. You can choose somewhere within this range to be safe for the LED. So I'm going to say that it's going to have at least 2.8 to 3 volts. Okay, so I'm going to choose 2.8 volts. I'll write that here, 2.8 volts. And for this, I'm going to choose 15 milliamp. That's a really good beginning thing for cheaper LEDs, I feel. Now again, most LEDs come with this really cool breakdown of the LEDs. This one doesn't have it. Again, just to stay to a language, this is called a VF, okay, forward voltage, and this is called an IF. Okay. So we know one thing about this power supply that's on the breadboard. It's at 5 volts. 5 volts. So we can use that in this thing. And how we do that is first we establish some more room here. I feel the picture camera is taking up a lot of room here. So we have 5 volts. And this is 2.8. So we do minus 2.8 volts. Okay, and what is that? What is 5 minus 2.8? Whip out the little calculator here on the screen. 5 minus 2.8 equals 2.2. Alright, sweet. So we got T equals 2.2 volts. Alright, so we have this cool little thing. I call it Ohm's triangle. V, I, R. Burr. So in order to complete this triangle, you have to put 2 divisions and a times, like that. And then just a little line that goes here and a little line that goes here. Pretend these are walls. And then I draw a triangle. Alright. So what we are missing, we have the voltage. We know it's going to be 5 volt. We have the LED voltage. Okay. We have the milliamps. What we're missing is this dude. Okay. So that dude is the I. Okay? That is the I. It stands for the amperage or the ohms of it, or the tolerance of it. So we're going to go like this. We're going to cover over the I, but we're going to write that down. We're going to go I equals voltage. We know the voltage to be 5 volt minus 2.8, because we got to calculate for this forward voltage. So we got 2.2 volt. Okay, then we're going to go divided by what? 15 milliamp. How do you write out 15 milliamps down here though? We got to convert it over to amps in order for that to work. So to do that, all you do is times it by 1000. So you get 0.015, because I've done it so many times. So take milliamps, times it by 1000, and you get amps. That's how you write that down. And if you ever want to go back, you just divide it by 1000. Alright, so we got this. I equals this. So we're trying to figure out this. So let's type this into a calculator. Should put a calculator up in the corner. That'd be sweet. Okay, so 2.2 divided by 0.015 equals 146. Nice. So this should be 146 ohms. In order to light this LED at its brightest-ish. And that's, again, that's all, it's a hypothesis, okay? That's based upon LEDs, their voltage, being around in a range, so it's based upon my experience. So these are things that you have to kind of get to the point where you can run experiments too. So don't worry, you'll have tons of opportunity because there's tons of LEDs there that you can try them on. So we don't have a 146 ohm resistor. This kit came with 220. It came with a 100. Okay. So we have a 220 on 100, and we got a bunch of 10s. Got an idea. So I did peel off 3 10s. I guess I can do one more. This is going to be really complex on a breadboard though, okay? So just bear with me. and I'll show you how to tie it all together. In the next experiment, it's not so bad, because we have this weird resistance value. So you can add resistors together. Okay, you can add resistors together. That's how it works. So these are all 10. So I start with the red, like that. So the positive. Then I jump this channel, just like that. And then I jump to another number. We're going to choose 19. Okay, we're going to jump the channel of 19 again. So there's 40 ohms. So let's just do a little calculation right now. So again, what I'm going to do is probe. We'll put one probe here. We're going to put probe here. And we're going to turn our multimeter on, and we're going to see what we got. 42. Okay. Alright, now I need a 100 ohm resistor. I think it's this one. So I'm just going to probe it. Nope, that's 1,000. That would be too much. Okay, good. Okay, so we need 100 more ohms. So again, this is how I do that. It's running from the positive. Boom, 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 boom. Jump. 19. Jump the channel. 19. Jump the numbers. I'm on 23. And if I probe that again, what do I equal? 144. Whoa, look at that. 144. Nice. Okay. It's almost perfect. So now I grab my LED. Okay. Remember, this is all positive so far. So I'm going to take my positive lead of my LED, which is the longest LED leg, and put it in the channel of 23. And now I'm on 25, and I need to run my ground. So I run a ground from that to that, and boom! Look how bright that is. Nice. So a good test of this to make sure that it's not burning out is just, just generally go like this, see if it's getting warm. And it's not, but it's super bright. And they do make like, I think it's 120 ohm resistors. They have like 140, I think, but they're rare, so you have to kind of mix and match different values. But the end of the story is, what I wanted you to get out of this lesson is you can add resistors together in a total to get how many ohms you need. That's why I did this. Alright, so that's our very first LED circuit. So now what I want you to do is go to the next one, because I always feel that if the instructor covers it twice, you are then able to go out on your own and try the rest of them. And as a homework thing, I would like to see all these, all the colors represented. Every color has a different value, by the way. So that's another thing. These are not all the same value. The green ones are actually the most forgiving ones. I cheated. The red ones are the very, very easy to burn out. So I would start those at like on that range of values. I would probably start that to be really low, like the 1.5. Alright, let's go to the next video.